Now we're going to go ahead and talk about sine, cosine, tangent ratios. These ratios always work because all right triangles, if they have at least one, so if I have another right triangle that's a little bigger and they both have the same angle, that means these are similar triangles. And so the ratio of the sides will actually be exactly the same based on similarity. So for that reason, there's a relationship between all of the right triangles that always stay the same. And so we actually have some right triangle math that we can do. So a lot of people remember this right triangle math as SOHCAHTOA. I'll explain that in a second. But first, if I have an angle right here, so usually they put a little theta, so we're marking angle A. Based on that specific angle, the opposite side is the one that's not touching it. So they consider this the opposite side. The adjacent side is the leg touching. So this is the adjacent side touching that angle. And then the side across from the right angle, as you know, is the hypotenuse. There we go, because I can spell. So sine, which I left space up here and I realized that's also down here, so it doesn't matter. Sine of theta, according to what this is saying is it's the opposite over the hypotenuse. Cosine of the angle, according to the ka, is the adjacent over the hypotenuse. And TOA tells us that tangent is opposite over the adjacent side. So some people will write it as S equals like this. So let me write it sideways. This is their shorthand. SOHCAHTOA. Just so they remember which one goes with which one. Okay. So the important thing we have to remember is which angle we're using. So we're going to go ahead and try tangent first. So tangent is opposite over adjacent. And in this one, they're asking us to do the acute angles. So that means angle R for one of them and then angle S for the other. Okay. So we're going to go ahead and do tangent of R. Let's start with R. So tangent is opposite over adjacent. So for angle R, our opposite side would be 45, and our adjacent side would be 24. So because it's tangent, we ignore this 51 because that's the hypotenuse. The hypotenuse will never change. That one's always across from the right angle. The adjacent and opposite do change depending on what angle we're using. So now if I use S, tangent of S, notice it just flips because now our opposite side is 24 and our adjacent side is 45. Okay, so same thing over here. We're doing the same thing. Oh, it did say for us to round, so let's go ahead and just type 45 over 24 in. And we get 1.875. And 24 divided by 45 is 0.5333. Because it says to go to 4 decimal places, so this should technically be a 0. All right, so number 2, same idea. We're going to go ahead and find the tangents of both of the adjacent or the acute angles. So we have tangent of L, and it's L, the opposite side from L is 5. The adjacent side, the one touching that's not the hypotenuse, is 7. And let's type that in. 5 over 7. 0.7143 approximately. So then we'll do tangent of J, and tangent of J just goes the opposite because J is right here, so we go opposite is 7 over our adjacent is 5. This is 7 over 5. If you type that in, it's 1.4, and this is not approximate, this is equal to, so it's 1.4000. Let's do the same thing with sine and cosine. So we're starting with sine of f, sine of g, cosine of f, cosine of g. Oops, something happened. So sine of f, or sine, remember, is opposite over hypotenuse. So if we go to f, our hypotenuse is right here. The opposite side is 12. So we have 12 over 13, which if we type in 12 over 13, we get 0.9231. So I'm going to do the same thing for angle G now. This will always stay the hypotenuse, so I shouldn't have erased that. So I'll always put that for H. So G, the opposite side of G, is now 5. So we have 5 over 13. And 5 over 13 is 0.3846, approximately. All right. Let's go to cosine. Cosine's adjacent over hypotenuse, so we still use the hypotenuse. So we'll go to f first. The adjacent side to f is 5. So 5 over 13, which is the exact same thing as what we just did. And then you'll notice that when you go to G, the adjacent side is 12, and we still are over 13. So it's going to be the same answer as that one. And that should always happen. There should be some that match up. All right, let's do the same thing for this one. So sine of f, sine of g, cosine of f, cosine of g. All right, I'm going to move that over just a little bit. Okay, so remember, sine is opposite over hypotenuse. The hypotenuse is the 97. In fact, cosine is adjacent over hypotenuse. So I know all of these are going to be over 97. So that's a given because that's our hypotenuse. And it looks like I should have given myself a little more room between these, so I'm just going to move these away from each other. There we go. Okay, so now let's find for the sine, if we're going to f, the opposite side would be 65. So 65 over 97 is approximately 0.6701. Let's go to sine of g now. So if I go to g, opposite of g is 72. So I'll do 72 divided by 97. I get 0.7423 approximately. Now I'm going to go back to f, but this time we want the adjacent side, so the one touching f. So that's 72. So it'll be the same thing as this other one, so the sine of g. And that means cosine of g should be the same as sine of f. And so I fill that in.